All right, today we're going to go into the next section of chapter 4, which is going to deal with rotations. And so with rotations, this is one where, as you watch the video, some of it will be hard to follow along with because I can't do the animations I normally would in my PowerPoint. So if you're confused by any of the methods that we talk about today, you can always ask in class. We can show you what it looks like in person if you need that clarification. So what we're talking about with rotations is basically we're just going to pick a point that we're going to call the center of rotation. For our purposes, that's just going to be the origin of our coordinate plane, so the point 0, 0. But what we're going to do is we're going to take a point and we're going to rotate an object around it. So we have this triangle WVU here that we're going to go ahead and rotate around point R. So see how we kind of just rotate it up, almost like we're just spinning it around in a circle there. So a couple things about rotations. First, rotations are rigid motions, which means they stay the same size. So that's a term you need to kind of remember as we go through this chapter, so they stay the same size. We don't change the figure to get bigger or smaller when we rotate the object. The other thing that's really important is that all rotations that we do will be counterclockwise, meaning we go against the clock. So it'd be in this direction here. When you rotate, points don't move any closer or farther away from the center. So in this case, point V here is exactly the same distance from the center as point V prime would be. So as we rotate it around, all the points stay the same distance away from the center. So the big thing again, counterclockwise rotations. Now, when we go to rotate 90 degrees, okay, so we're going to start with our pre-image triangle ABC. That's this angle or triangle right here. So this is our original picture, and we get the coordinates right here on the left side. So A was at 1, 1, B was at 2, 3, and C was at 4, 1. So that's our original. Now, there's two methods to rotating an object. The first one, you could use this formula that we see down here at the bottom. So rotating 90 degrees, it says take any of your original X and Y coordinates, flip the X and Y, and then change the sign on Y. So one thing that we want to be really careful with, this just means change the sign. It does not mean make it negative. So if it's already positive, then yes, you'll make it negative. But if it starts negative, you want to make it positive. So if we look at what happened here, for point A, we had 1, 1. So X was 1, Y was 1. We flip those, make Y negative, so we get -1, +1. And that's where A prime comes in right here. And then we have B was at 2, 3. Well, so we flip the X and Y, so now 3 comes first and 2 comes second. We change the sign on Y so it becomes 3, or negative. So we have -3, +2. That's where B is right here, B prime. And then C, the same thing. We flip-flop X and Y, so we get -1, +4, and so C prime goes here. And so now we have our image of our rotated triangle right here in the second quadrant then. Now, the other thing that we can do here, besides using the formula, so if you don't want to have to memorize a bunch of formulas, then the other thing you can do is if you take your page, and so as I'm doing this, maybe you want to kind of follow along, but you're going to take your page and you're going to rotate it around onto its left side. So you're going to actually take the physical paper and flip it onto its left side. Now, when you do that, this triangle ABC that we currently had now should look exactly like this triangle that we're going to end up at. So when you turn your page onto its actual left side, you can see where the new points are going to have to be. And so then what you would do is record those points as you go. So A would have moved to -1, +1. As it's sitting on its left side, B would be at -3, +2, and C prime would be at -1, 4. So what you're doing is you're putting the page on its left side, and you're looking at where those points are now located on the coordinate plane. So now you look at where those new coordinates are, record the 3, and then bring your page back to normal and plot those 3 points. So that's one that's a little bit more visual type of method, one that's more hands-on. And if it doesn't make sense as I'm going through it on here, again, ask in class and we can show you what that looks like so it makes a little bit more sense. But you have the formula that you could use or physically rotate your page to get your new points as well. Another type of rotation we want to know how to do is working with 180 degrees. So again, we're starting with triangle ABC up here in yellow. So this is our original. Now for rotating 180, the formula, as we see down here, is a little bit more straightforward. X and Y actually don't change places, so we take the original X and Y, and all we're gonna do, again, if we think about what this negative means, it just means change the sign. So for X and Y, we're just gonna change the signs on them. So notice in the pre-image points right here. So A was at -1, +2, which means A prime is gonna go to +1, -2. So we just switch both signs and keep X and Y the same. And then B was at -3, +1, so B prime is gonna be at 3, -1. And then the same thing for C. C was -3, +3, we switch it to 3, -3. And then we plot those points. A prime at 1, -2, B prime at 3, -1, C prime at 3, -3. And then we connect our dots, there's our new image. Now again, if you wanted to actually do the hands-on method where you actually physically rotate your page, what you're gonna do this time is you're gonna take your whole paper and you're gonna rotate it all the way upside down. So when you take this and rotate it all the way upside down here, so you're gonna kind of come all the way around, what's gonna happen is triangle ABC ends up in its new location. So while you're looking at your page upside down, you're gonna look at where those points are. So when you rotate it upside down, you're gonna have A at +1, -2, B is gonna be at +3, -1, and C is gonna be at +3, -3. So then you record those 3 points, put your paper back upright, and plot them. And you'll end up in the same spot as what we had with our other method. And again, if that rotating method doesn't make sense as we're going through this video, ask in class and they'll be able to show you what's going on. For 270 degrees, again, we have a formula. So for 270 degrees, if we want to use the formula, it's a lot like the 90 degrees. So we're going to flip-flop X and Y, but this time X changes sign. Okay, so now the X is going to change sign. So as we look at our picture here, we start with A, B, and C on our yellow triangle here. That's our original. Now if I'm going to use the formula, A goes to A prime by flip-flopping X and Y. So the 2 and the 4 switch places, and then the X changes sign. So it was positive, now it becomes negative. Same thing with B. When I go to B prime, I flip-flop the 1 and the 2, my X becomes negative. And then we do the same thing for C, and so once we get all 3 points, we just plot them. So A is at -2, -4, B prime is at -1, -2, C prime is at -4, -1, and then we draw our picture. You should see the exact same picture that you started off with, just rotate it. So it should be the same exact triangle look, just rotate it however far. Now in this case, if you want to use the hands-on approach, for the hands-on approach, you're going to go ahead and turn your page onto the right side. So for 270 degrees, we'd have to go 3 different times around. So in this case, the page is going to end up on the right side. So if you rotate your page physically onto its right side, what's going to happen is your triangle ABC is going to end up right here where A prime, B prime, and C prime should be. And so as it's sitting there on its right side, you would record where A prime, B prime, and C prime are, turn your page back upright, plot the points, and then you get your final image. Okay, so that would be kind of the hands-on approach if you don't want to memorize the formula. So now if we take a look at the next one here, back to rotating 90 degrees, and again you can do this one of 2 ways. Take your page, flip it onto its left side, record the new points, flip it back and plot, or use the formula. So flip-flop X and Y, make the Y change signs. So -3 became +3. For B to B prime, we switched the X and Y, my -4 became +4. So just doing that all the way around, and then we just go ahead and plot the new points and get our new figure. Now the last thing we have to talk about today is rotational symmetry. For rotational symmetry, and again, this is something that you might have to kind of have us explain in class because it's a little bit tough to explain on here. But a figure has rotational symmetry if we can spin the object and get the same object looking back at us. So for instance, if I look at this trapezoid here, or I'm sorry, this parallelogram, when I look at this parallelogram, what you're going to do is you're going to put your pen or pencil right in the middle of the parallelogram. So you're going to kind of put a point like right in the middle there, and you're just going to hold your pen or pencil right in that spot. And then you're going to slowly start to rotate your page. So you just kind of start spinning it in a circle. Now what you're going to do is you're going to count how many times you see exactly this parallelogram again. So what should happen is, as you put your pen or pencil right in the middle of the figure, when you start to spin it, you should get the same exact parallelogram looking back at you when your page is completely upside down. So that would be one time that we see the new parallelogram. And then as we continue to spin after that, we have to come all the way back around to get the same parallelogram again. So the only time we see exactly what we're looking at right now is when it's upside down and then back right side up. So what happens is that tells us there are two rotations. And so one of the things with rotational symmetry is now we know that yes, this has rotational symmetry because I was able to spin it and find the same object. But the other thing it tells us is that the angle of rotation would be 360 divided by my two rotations, and that's where that 180 degrees is coming from. So I can spin it 180 degrees and get the same parallelogram back. Now if we look at this triangle, so as we look at this equilateral triangle here, again, you're going to put your point or pen or pencil right in the middle of this triangle, start spinning your page slowly, and as you rotate, you're going to count how many times you get this exact triangle back. So what should happen is as you rotate, you should get the triangle twice on the way around, and then as you go all the way back to the original, you get a third time. So in this case, for this triangle, it has rotational symmetry. There are 3 rotations, which means the angle of rotation is 360 divided by 3, or 120 degrees. So when you're spinning your page, you're just looking for when do I see exactly that same object again, and then you just count how many times do I see it all the way around to when I come back. Same thing with the star here. As you look at the star, when you start to spin it, every time you rotate, so as you put your pencil in the middle and start to rotate, you're going to get 1, 2, 3, 4, 5 different times where you see exactly that same star. So as you continue to spin, you're just counting how many times do I get this star to show up again. And so that's where we have yes, it has rotational symmetry. The angle of rotation would be the 360 divided by 5. And so that tells us it's 72 degrees. Now the other thing to make note of here, there are times where we might be interested in more than one single move. So like 72 degrees would take point A one space counterclockwise. So if I said apply a 72 degree rotation, A is going to come down to here. Okay, but I can move A more than one spot because there were multiple stops along the way. There were 5 to be exact. So if I said I want to move A 2 spots, so all the way over to here is where I want A to go, then what's going to happen is I have the first rotation here would be 72 degrees. My second rotation would be 72 degrees, and so if I add those together, that would be a 144 degree rotation. So 144 degrees gives me the same star, it just moves A twice instead of once. So you might do multiple moves at a time with this rotational symmetry. For our last example, we have this triangle here. Now, as far as this triangle is concerned, if we put our pen or pencil right in the middle of it and start to spin, we're going to go all the way around the figure and never see that triangle again. It's going to have to go all the way back to the original to get this exact same triangle back. And so if that ever happens where you have to spin all the way around and before you get the same figure back, then this does not have rotational symmetry. So you would say there's no rotational symmetry for this particular object. So that's another thing to kind of keep an eye on different shapes as you spin it. If you never get that same object back, it just means there's no rotational symmetry. If you do, count how many times it happens. That's going to tell you your angle of rotation. So with that, you should be able to complete today's assignment with a worksheet. If you have questions on anything, ask in class or email. And then just kind of try to work through what you got here, and then we'll review these last 3 sections here before we quiz next week. So just be ready for that as well.